Okay, so this is video 2, looking at sleep for Unit 5. I broke this video apart into 2 parts because it was a little bit long. So this is the first part on sleep. It will talk about the stages of sleep. It'll talk about your brain waves, what occurs in the different stages, talk about the different reasons why we sleep, and then lastly, it'll talk about the loss of sleep and sleep deprivation. Part 2 will talk about the sleep disorders. So make sure you watch the second part, which will cover the different sleep disorders. So first off, sleep again is an altered state of consciousness. So we talked yesterday about consciousness being the state of alert. Sleep is an altered state. Sleep occurs because our conscious fades, activities in the loads begin to slow down, and then the sleep area kicks in. Every 90 minutes, we pass through 5 distinct stages. So again, this is going to talk about the sleep stages, what happens with sleep deprivation, and then the theories of why we sleep. So you want to pause this and you want to write down each of the different stages, the brainwave activity, and then brain activity that's taking place. So the first thing that we happen is we have the awake state. In your brain, you have beta waves that are active. So right now you have beta waves occurring in your brain. And your brain exhibits low amplitude and fast irregular beta waves when your brain is awake. Then you have stage 1, which is also known as a non-REM stage. We have alpha waves that begin to occur. During early light sleep, the brain enters a high amplitude, slow, regular wave called alpha waves. You experience dream-like experiences during this time. Okay, and you also begin to have hallucinations. Now, you're not dreaming in this stage, but you're having dream-like experiences and hallucinations during this time where you're fading between awake and not awake. Stage 2 then begins about 15 minutes in. It's another non-REM stage. During this time, you have what's known as theta waves. Theta waves are brain waves that are slowed down even more. You begin to exhibit sleep spindles, which are little wave bursts. You have high amplitude waves. Oftentimes sleep talking can occur here, and half the night is actually spent in stage 2. Stage 3 and 4 are very similar. Okay, some people believe that we should just have stage 3 and 4 together. It's another non-REM stage. During this time period, both stages have experienced delta waves. There are large amplitude, slow delta waves. The brain wave cycles are less than 1 cycle per second compared to 15 cycles when you first fall asleep, so it's really slow waves. It's known as your deepest sleep, and oftentimes sleepwalking, which we'll get to later, sleepwalking occurs at this time. And then you have the REM stage, which is known as rapid eye movement. It's stage 5. You have beta waves and alpha waves occurring at this point in time. And after reaching the deepest sleep stage, which is 4, the sleep cycle starts moving back towards stage 1. Although still asleep, the brain engages in low amplitude, fast and regular beta waves, much like when being awake. This is the stage that's known as rapid eye movement. So again, you want to make sure that you know each of the different stages, the different brain waves that is occurring in each stage, and some of the big things that occur in the brain activity for each of the stages. For example, hallucinations and sleep spindles. You'd be able to identify them with the right stage. So what are hallucinations that take place during stage 1? Hallucinations are sensory experiences that occur without a sensory stimulation. They're known as hypogenic sensations. The sense of feeling that you're falling, but you're not actually moving. That's a hallucination that occurs. What's the difference between the non-REM stages, which are 1 through 4, and REM stage? Well, the non-REMs are stage 1 through 4, and during this stage, no rapid eye movement. And the way that it occurs is you have your experience stage 1, then you go to stage 2, then you experience stage 3, then you experience stage 4, and then you actually start experiencing stage 3 again, stage 2 again, and then you may experience the REM stage. And each of these is the REM stage. And you could see as the time goes on, the hours in which you sleep, actually REM gets longer and longer. So most students think that you just go stage 1, stage 2, stage 3, stage 4, stage 1, stage 2, stage 3, stage 4, but actually you go through kind of a little flow where you go 1, 2, 3, 4, 3, 2, 1, etc. Again, here's another example of the different stages, very similar. The cycles in a typical night's sleep, most people pass through the 5-stage sleep cycle. And again, the graph shows several times with periods of stage 4 sleep and then stage 3 sleep actually diminishing, and the REM gets longer and longer. So that's another thing too, is stage 3 and stage 4, the length of it gets shorter and shorter, and REM gets longer and longer. Here's another graph. Another graph B plots the increasing REM sleep and decreasing deep sleep based on the data from 30 young adults. So here you could see is REM is actually increasing and stage 3 is decreasing on the chart. What is REM sleep? REM sleep is known as rapid eye movement, the similar brain activity to stage 1 where you have alpha and beta waves, but unlike stage 1, your heart rate increases, your breathing becomes rapid, and every half a minute or so, your eyes dart around. You have vivid dreams during this time period, so this is when you actually dream, and after several cycles of stage 3 and 4, they get shorter and REM gets longer. Eugene Asinski, and he studied this at the University of Chicago in 1952. You could see normal brain activity. Here's some activity that may be taking places in your pons and in the limbic system. And with REM activity, you're actually very active throughout the entire brain. So here's an example of the different brain waves that occur. You can see that the amplitude is very little, low, okay, in the burst of activity. And as you get into 2, they get a little larger and larger as you're getting the alpha waves here. Stage 2, then you start having little sleep spindles. Here you have your theta waves. And then stage 3 and stage 4, there's a lot more, I would say, higher amplitude in stage 4 than stage 3, but you have your delta waves. And then your REM activity, very similar to they state stage 1 in terms of brain activity. So what happens if you don't get enough sleep? Sleep debt is accumulated hours of lost sleep. So this is if you don't get enough hours of sleep. Most adults need about 8 hours of sleep or a little more to feel good and functioning. Most adults are only getting 5 hours of sleep during the week. So now you're losing, if it's 3 hours a night times 7, you're losing, or it's 3 hours times, you're losing about 4 hours a day then. 3 to 4 hours, it can make up to 30 hours of lost sleep a week. And you can't make it up on the weekends. There's no way that you can ever fill the sleep debt that you're creating. Most Americans get significantly less than 8 hours of sleep. A century ago, people were getting more sleep. However, since the invention of the internet, social media, lights, TV, we're getting less and less sleep. Measuring brain activity, they do use EEGs in order to measure brain waves. And if we do have a lot of sleep debt, that ends up with us experiencing sleep deprivation. And this is the condition of not having enough sleep. And how this affects our body is we have fatigue and slower reaction time, impaired concentration. We depress our immune system, greater vulnerability to accidents, increase in depression, increase in weight. The more sleep we actually have, the longer the life. This can cause long-term memory impairment and emotional irritability. And when we do have sleep deprivation, the next time we do sleep, we actually experience longer REM sleep because our brain is trying to catch up on that sleep. So REM rebound is the lengthening and increasingly frequent and depth of rapid eye movement in sleep, which occurs after periods of severe sleep deprivation. You could see what happens with sleep deprivations, and this is, it's looking at 2 charts between accident frequency, and this is how many accidents we have, and this is the Monday before daylight savings time, and this is the Monday after, and you could see that we lose an hour of sleep, so people become more sleep deprived, and the Monday after, before daylight savings times, there's not many accidents, but after, because we lose that hour of sleep, increases about 200 more accidents. Again, this is in fall then, we actually gain an hour. So we're getting more sleep the Monday after. And you could see that when we get more sleep, accidents are actually decreasing by about 200%. So this is one of the ways that they looked at sleep deprivation.